Hello there, viewer. So, welcome to the episode 2 of creating a sliding puzzle game. Let me quickly open my Godot in game engine. So, let's go to our project, sliding puzzle project. So, in the previous episode, we actually created a movable entity and we moved it. So, I showed you by creating one and moving one. So, we used the keyboard input to move the entity. So like input to some output like output on the display, and we use the input of the keyboard like that mapping. So now in this episode, let's actually see how it works and are there any flaws. So let's see the output again. So here you can see this is our entity right here. This is the icon I gave it. I gave it the icon of game engine itself. Now let's see that are there any flaws or not. So first of all, let me give you some. So it moves right here. You know that it moves, but we cannot see some flaws in it unless we increase its speed. So let's just increase its speed. Maybe let's say 125. So let's see. Okay, it's moving way fast now. Let's move it one direction. Wait, its speed increases. Look at this. Normal speed or normal speed. Normal speed, speed increased. Speed increased. Speed increased. So you can say that its speed increases when it's moving diagonal, which means that's a flaw. We need to not increase its speed even if it's diagonal. To actually fix this problem, what we need is to normalize the direction vector. For this, we have to create another variable. So let's just create another variable right here. We will call it direction underscore normal. All right. So direction underscore normal is equal to. So here is our direction vector, and now let's normalize it. To normalize, we will simply write direction dot normalized and then give it some curved brackets. And now with speed, we also need to use direction dot normal because that's our normalized vector of direction. Now let's see if anything happens like that. So let's just move it. This is normal speed, this is normal speed. This is normal as well, and this is normal as well. You can see now that the speed is not increasing, which means that it works now. Now its speed in all the directions, including diagonals, it's the same. This is consistent and this is good. Now what we can do, we can actually create more of those movable entities. We can actually create a function right there so that we can have more movable entities. So let's actually create a function. So let it be kinematic body setup. So this is a function kinematic body setup. Now what we want is we want this function to create more than one kinematic body. So that for that purpose we can use a loop. So let's say for I in range, let's say that we want to create 2, so we will write here only 2, which means the loop runs only 2 times. Now we can copy this bool code, which actually is used to create a kinematic body, and give it a look, a texture as well, and position, and then connect and then add it directly as a child of not 2D. We cut this code from right here and we simply paste it right here. Now this will create more than one kinematic body. Currently it will create only 2. But because we want it to work, so we will actually we will write this function directly under the function ready. Why? The reason is that function ready runs one time before the function physics process is there, and we want this function to run one time so that it actually creates all the kinematic bodies. All right, now let's see how it will work. But there is one flaw in this code right now, and that is that the box dot move and slide. This flaw, why is this is a flaw? Basically, it will move the latest kinematic body being created, not the previous ones. And there are some more flaws in this code. I will show you right away. So it did not created. Actually, it did created. It did create a kinematic body, but it looks like it's only one. Here is it. So basically there are 2 kinematic bodies right now. But the problem is that both of them can cross through each other because they don't have a shape. And not only they don't have a shape, but also they do share position if you run the code. Let's say that we don't want them to share position. We're going to give them distinct position by using the variable I, because initially the variable I is 0, then it comes to 1, and at 2 or after 2 it does not work. So let's say that we want them to separate. We want them a distance of 64 pixels between them. So we will use this and then multiply 64 with I. By the same variable which the loop is using. Now they will have distinct positions. You can see they are side by side, but only one is movable. The other is not movable, because it only moves the latest kinematic body being created. It does not move the previous kinematic body. And not only this, we can create more than 2. Let's say we want 3 kinematic bodies right now. So we just change the loop variable, I mean the range, the capacity of range, and now we have created more than 2, 3, but only one is movable, and which is the latest one, which was created at last. But now what if we want to move all of them? So we need to give them some kind of distinct thing, like a feature, like a property, like something which actually identifies all of them distinctively. So for that we can actually define, let's say we define one more variable. Let that be boxes, and let boxes be an array. Now we will have another function right here. let it be kinematic body storage setup. So in this function, what we will do, we will actually use a loop. We will use the loop to be this, we will set this capacity of this range, this loop, the same as the loop used in the kinematic body setup, because that's important. Now, let's say boxes I is equal to null, which means when I was 0, the boxes 0 represents the first element of boxes, which we set null. Then I equal to 1, second element to null as well. Then I equal to 2, third element null as well, which means all the first 3 elements identified as null, which the storage setup is complete. Now what we need is to identify it. So how we do that? We do this right here. So boxes I is equal to box. This is it. So all the 3 boxes right here are distinctively can be differentiated easily. So first box means boxes 0, second box boxes 1, third box boxes 2. So they are differentiated elements within this array, which means we can use this array to differentiate between them. Now what we want, we will get to our ready function and we will copy this function's name and set it right here as well. Why? Because first we want this to run. All the boxes, all the potential positions of the boxes will be null, the array boxes. But after that, this function will run, this one right here, kinematic body setup, which means that the boxes will not be null, they will be changed from null. After that, we will be passed the physics process function and we can use here movement. But now, what we want is a new function to differentiate between the boxes actively. Let that be selected box. Selected box will be of the function which will differentiate actively. But let's define new variable. That would be selected box as well. So a variable selected box and a function selected box. So in the selected box function, we have to create some way of saying what box is assigned to what thing. All right. So let us create a dictionary. Let us call that key map. We call it key map. So we need to define a variable as well, which would be key map. So there is it. So there is it, our variable key map, and now we need to define it as a dictionary. Dictionary is defined in curly brackets. So dictionary is used to pair keys to keys to elements, maybe strings, maybe arrays, like that stuff. So we can use any key to map to maybe another data type, like that. So for example, let's call, first of all, let me say key q, and we actually, let's say we map it to boxes so 0. We'll copy this, paste it up, but here we'll go W, and here we will go with 1, and then paste it up another time, and now we'll go with, let's say, E, and here we go with 2. All the elements of the box in the boxes array are paired to all different types of keys. Now, why I used capital keys? Because this actually represents the Q letter on the keyboard. So this maps input to a box, input to a box, input to a box 3 times. After that, we need to use a loop for let's say for key in key map.keys. If input dot is key pressed, so now we will write here simply key. All right, selected box will be key map key. This is it. So the selected box function allows us to select a box. This is it. Now we will use this function. We will copy this one in the physics process right here, and we will see how this actually works. Okay, so there is an array right here, invalid set index 0 with value of type null. Set index 0 on base array. Maybe let's just not do this one right here. So let's just comment it out, all of it. We'll comment it out all of it, so actually you can use it. We'll comment it out, and we can actually type here. And now in the function ready, let's comment it out this as well. So now let's see. There it is. Now okay, so actually this is not working because there was one key mistake right here. That was we never changed in the movement that it's not about box, it's about selected box. So now it should work, I think so. Let's rerun this. Non-existent function move and slide in base nil. So there is an error right here. The error says non-existent function move and slide. I think I need to work with this error in background for some while because debugging takes some time. Alright, I think it's enough for the episode 2, but I would surely, in the next episode, I will surely tell about about this error, what happened to it. And hopefully, I think so in the next episode, I may debug this one as well. Thank you for watching, and if you like this video, consider liking it, consider subscribing for more videos. All right, I will see you in the next episode.